What I'm going to show you today I hope you'll find quite cool, especially if you're interested in vision systems and how they might work, specifically Cognex ones built in the Inside Explorer using the spreadsheet builder. I'm going to show you how you might use geometric shapes and pattern matching to identify different components and how you would measure the distances between them to determine if mounted in the correct position or even at all. On the screen you'll see I have an integrated circuit chip and a buzzer mounted on an electronic development board. I'm going to move the buzzer slightly to the left so we can watch the status at the bottom of the screen go from pass to fail in real time as it shows up on the screen. You see I've moved it slightly to the left. At the bottom of the screen it says fail. Today I'm going to show you how to do this. So getting the camera set up on the network and calibrating it could be their own separate videos, so I'm going to stay on topic here and just talk about the program. I've set up the camera to be in continuous mode so we can see it changing in real time. Then I've opened up the spreadsheet view and I'm going to be finding a pattern which I know to be consistent throughout the whole process. So if you could imagine a previous inspection step. So I'm going to say that this chip here is in the correct location. I know this for a fact. I've selected a bit outside of the bounds so it can get a bit of location on where on the breadboard it is. And I've just adjusted the angle range there so I could change it to 180, up to 180 degrees. So you select the region and then you select where to look for this. So I've basically selected the whole image. And great, you can see score of 100% because it's default image. I'm going to copy that. I'm going to paste it down here and I'm going to do the same thing for the buzzer. Except for this time I'm going to move the model region over here. I'm going to select a tiny bit outside of the pattern that I'm looking for, just so I know what to expect when I move it in future, because there's some component drift on this item. So here you can see I've done very similar to last time. I've just slightly adjusted the angle and I've selected for the graphics to show the inputs and the results, and I've gone back there and I've done the same on the previous pattern. Now I'm going to look for something in relation to the first pattern, which is the integrated circuit chip. So I'm going to be looking for the side of the edge, so I'm going to be looking for a find line, and here I'm selecting with what to reference. So I'm referencing the integrated circuit chip and I'm going to be looking for a transition from dark to light which is within the distance of the integrated circuit chip. So you can see there I've done it on the left hand side and I want to do it on the right hand side too, and you can see that graph at the end. So I'll come back to that actually, sorry. If you notice the red arrow up the top, that's how the camera processes the image, so it's right to left, but you can rotate that in any direction you want. I've kept it standard for the whole program here. I just noticed that the center of the object I was looking at was a little bit off, so I adjusted it to my liking. Now that we have an idea of where everything should be on the board, we can do some measurements. So I'm going to measure the edges. So this could be like a default, you know, if the reason why I did this is after the measurement, if the measurement ever changed, which it shouldn't, it would mean that the camera has moved up or down or is out of place and would have to have maintenance done. But this isn't like a key process parameter. The key quality attribute we're looking for in a moment is going to be a distance between the IC and the buzzer. So this is a midpoint to midpoint one, and here you can see I've done a point to point. You can see two green lines there on the image. Now I'm going to be looking for what range, what tolerances. This is where you set your tolerances here. So I've just set them plus or minus 5. These are pixels, but you know, calibrate them to millimeters. It's quite straightforward. So you see here you'll get a boolean, a 1 or a 0 if it's in range or if it's not. And next I'm going to put up a little graphic just to show, like, if it's in range, a green light will come up and say pass, and if it's not, fail. Copy paste that, make sure they reference the correct output. Yep. Cool. And now I want to do a little graphic on screen itself, so you don't have to be looking through this transparent spreadsheet, and you can actually see the results on the screen as you're going. So I've just put down two strings, pass and fail, and I wrote a little if statement saying that if the distance between the chip and the buzzer is in range, say pass. If it's not, say fail. And then in a moment, yeah, I'm just selecting the cell to pick there, and then in a moment then you'll see me putting down a plot for plotting a string onto the screen. And here you see me referencing the if statement output, and then just adjusting where the label will appear on the screen. You see it down there on the bottom, it says pass. So the distances is perfect. Just going to save it. Go online. You see me coming in here now. I want to take this board away and I want to move this buzzer slightly to the left. Fail. Bring it back into its location, pass. That's how you use geometric shapes and patterns to locate components and measure the distances between them. I hope you enjoyed this video.